Get ready to torque your nuts, harden your springs, and forge your mind into a bulletproof study guide. We are mechanical engineering made simple. Welcome you to the deep dive on a philosophy that, well, fundamentally changed how the world manufactures everything. Lean manufacturing and the legendary Toyota Production System, or TPS.
Yeah, and it's really more than just, an efficiency drive. This is a truly revolutionary engineering approach. It came from Taiichi Ohno, and it's deeply rooted in precise measurement and just this relentless focus on delivering actual value. It's really a total rejection of those old, clumsy mass production methods.
Right, the high inventory, functional silos way of doing things. So our mission today is basically to give you the shortcut. We're going to break down the core concepts here, the structural pillars, the key engineering metrics, and also the deep, often ignored cultural stuff.
The cultural requirements.
Yeah, the things you absolutely need to transform a plant into a highly flexible, responsive system. Basically, we're learning the science of waste elimination.
And when it's implemented properly, the results are, well, they're dramatic. That's why we're diving in. The ultimate goal here, it's achieving huge resource savings. We're talking things like half the human effort on the factory floor.
Half. Wow.
Yeah, half the floor space needed, half the investment in tooling, and crucially, way less than half the inventory.
Well,
And all that while delivering fewer defects to the customer. So quite something.
let's unpack this then. Let's start where Ono started. The absolute elimination of waste. The Japanese term is muda, right?
That's it, muda.
So what exactly qualifies as muda in the TPS context?
Okay, so muda, or waste, it's defined as basically anything that prevents the value-added flow of material,
Yeah.
from raw goods all the way to the finished product. But the most critical part of this definition, really, is that the customer is a final judge. They decide if value has actually been created.
Ah, that customer focus changes everything for engineering goals. So how do we figure out what's true value add? You mentioned two criteria.
Yeah, two non-negotiable criteria. An activity only adds value if it meets both. Okay.
Yeah.
First, it has to physically add to the form, fit, or function of the product itself.
Makes sense.
Second, and this is the key, it has to be something the customer is actually willing to pay for.
Willing to pay for. Okay, that distinction really does turn traditional thinking on its head. So things like transportation,
Waste.
inspection.
Waste.
Okay, but hold on. I have to push back a little here.
Sure.
If I don't transport a part, it never gets to the assembly line, right? And if I ship, say, complex engine parts without careful packaging, they'll arrive damaged. So isn't that protection kind of necessary? Isn't it value added in a way?
Ah, you've hit the nail on the head there. That lets us distinguish between pure waste and what we sometimes call necessary waste. True lean thinking actually categorizes all non-value-added activities, even the necessary ones like protection and transport, as muda.
Okay.
The goal isn't just to get rid of the obvious pure waste, it's also to relentlessly minimize that necessary waste too.
Okay, that makes more sense. So the customer doesn't care that the material traveled, 25,000 miles through 4 suppliers.
Exactly.
Or about the 3 different types of internal packaging used. They just care about getting good value for their money.
Precisely. And that relentless external focus on what the customer values, that's what drives lean manufacturing. That's what pushes the efficiency gains through teamwork, open communication, smart resource use, and that idea of continuous improvement, Kaizen.
Right, Kaizen. So if value is the goal, we need the engineering structures to actually enforce it. And that brings us to those famous twin pillars of TPS, JIT, and Jidoka. We hear a lot about JIT, just in time. But let's start with the Jidoka. That's the one engineers often find a bit counterintuitive.
Like Jidoka. It's often translated as automation, or maybe automation with a human touch. It's really centered on using machines and people effectively together. But its core principle, the absolute directive, is this. No defective parts should ever be allowed to advance in the production system.
Okay, no defects forward. And that leads to the famous, or maybe infamous, Jidoka paradox, shutting down the entire line.
Yes.
Why on earth is stopping production the smartest move? I mean, every traditional incentive screams, keep the machines running no matter what.
Because Jidoka operates on this really profound principle.
Right.
Quality is production. They're equal. If a defect happens, the line has to stop immediately. Often it's an operator pulling an and-on cord.
The end on cord, right.
And it stays stopped until the root cause is found and completely eliminated. So the paradox is clear.
Yeah.
You shut down the system temporarily, so the system can actually run continuously and predictably over the long haul. If you let bad parts move forward, you just contaminate everything downstream. That leads to massive, hidden, really expensive rework later on.
So Jidoka creates this unshakable quality foundation. You mentioned Onio. The sources say he stressed they spent 7 focused years building that quality control foundation.
Yes, 7 years before they really embarked on quantity control.
That level of patience,
Yeah.
it seems almost impossible today.
It does, doesn't it? 7 years sounds like an eternity in modern business. But that cultural requirement, stopping the line, immediate root cause analysis,
Right.
it has to be deeply institutionalized before you start trying to speed up the flow. TPS, fundamentally, it's a system of quantity control that's JIT, but it's built entirely on top of a high-quality foundation that's Jidoka.
Okay, let's talk about that quantity control then. JIT, making what is needed only when it is needed. What are the key tools that enable that pull system? Getting away from wasteful push scheduling.
Well, the primary tool is Kanban. It's really revolutionary. It's the practice of using physical cards or sometimes other visual signals.
Like lights or empty bins.
Exactly. Visual signals to smooth out the flow and create a demand-driven pull system. It triggers replenishment directly from consumption right at the next process step. It controls inventory, minimizes that huge waste of overproduction, and makes sure flow is tied directly to actual customer withdrawal.
Okay, Kanban for pull. And the other key tool, the one that attacks the old assumption that you have to run huge batches to be efficient, SMED.
SMED. Single-minute exchange of dies. Developed by the brilliant Shigeo Shingo. SMED is basically a batch destruction technique. Its whole focus is slashing changeover times, ideally down to a single-digit number of minutes.
Single-digit minutes for a major machine changeover.
That's the goal. By drastically reducing changeover time, you drastically reduce the economic batch size. Smaller batches mean less waste in two key ways. Less excess capitalization tied up in tooling.
Right.
And less of that massive overproduction you need just to build buffer stock during those long changeovers. This directly enables JIT and dramatically cuts lead times.
Okay, so we have the philosophy eliminate waste. We have the pillars Jidoka for quality, JIT for quantity, enabled by tools like Kanban and SMAD. But how do we actually know if it's working? How do we measure success? That brings us to the engineering metrics. Let's start with the heartbeat of the line, takt time.
Right, takt time. Takt is the design process cycle time you need to exactly match the customer's demand rate. But it's normalized to your actual production schedule. It sets the absolute pace. And we calculate it using a pretty simple ratio. It's available work time divided by customer demand. So dollars available work time / customer demand dollars.
Okay, let's walk through a quick example, maybe conceptually, so it's easier to follow without complex math on audio.
Good idea. Let's imagine a plant needs to produce, say, 500,000 units per year.
Okay.
Now, based on your actual operating schedule, maybe 2 shifts, 5 days a week, minus holidays, breaks, planned downtime, you figure out your total available work time for the year in minutes or seconds.
Right, the actual time you can produce.
Exactly. So you take that total available time and you divide it by the 500,000 units the customer wants. Let's say that calculation comes out to approximately 0.56 minutes.
0.56 minutes, that's about 34 seconds.
Right, about 34 seconds.
So what does that 34 seconds actually mean for the engineers and the managers on the floor?
It means that if you want to stay perfectly in step with customer demand without building up wasteful inventory or falling behind, you must produce one good saleable unit every 74 seconds.
So it's a hard target.
It's a hard target set by the customer, essentially. If your current production cycle time for one unit is longer than 34 seconds, you get an engineering problem to solve. You won't keep up.
And if it's much shorter?
If your cycle time is, say, 20 seconds, you're going to build inventory like crazy. Expensive, unnecessary inventory. Takt time defines the rhythm.
Okay, takt time sets the rhythm. Beyond that, what else measures the ultimate health of the whole process flow? What's the big picture metric?
Lead time reduction.
Yeah.
Taichi Ono always hammered this. He said the key metric is, and I'm paraphrasing slightly, looking at the timeline from the moment the customer gives us an order to the point when we collect the cash.
Order to cash.
Order to cash. And we are reducing that timeline by removing the non-value-added wastes. Short lead times, he argued, are the true guarantee of flexibility, good quality, and stable processes.
Makes sense. Faster flow means less chance for things to go wrong, less inventory sitting around. And finally, there's the big diagnostic tool for equipment performance, OEE, overall equipment effectiveness.
Yes, OEE is crucial. It gives us one clear number for overall production effectiveness, combining 3 factors. The equation is dollars OEE equals A times Q times P dollars.
Okay, break that down, AQP.
Right, so A is availability is the machine running when it's supposed to be running. Q is quality yield, how many good parts are we making versus total parts started. And P is performance. How close is the machine running to its design cycle time or to takt time?
So if your OEE is low, where do you look first?
Well, if your availability, the A is low, that often points to serious instability. Machine breakdowns, long changeovers, basically, and engine problems needing Jidoka solutions.
Got it.
Cycle time losses, the performance factor, P, not meeting the takt rate. That's often the low-hanging fruit engineers can attack first to get throughput up quickly, maybe through SMND or work balancing.
And the tool used to actually see all this, to visualize the entire system before you start changing things. Value stream mapping, VSM.
VSM is absolutely the first step in any successful lean transformation. You have to do it. It charts every single activity, literally from raw materials coming in the door to the final customer delivery. And its specific purpose is to expose those huge amounts of hidden waste, unnecessary steps, delays, excess scrap, inventory mountains.
How's it different from just a regular process flowchart?
Good question. A simple flowchart just shows the steps. VSM visualizes the entire system, including information flow, inventory levels, cycle times, lead times. It shows the why you need to improve, the overall system performance, rather than just letting you optimize little isolated pieces of the process. It forces a system view.
Okay, we've covered the engineering tools, the metrics, takt, lead time, OEE, VSM. We've got Jidoka, JIT, Kanban, SMED. But the sources, and you've hinted at this, make it crystal clear. The tools. That's the easy part. The really difficult part is the culture.
Absolutely.
Why does management so often fail here? Why do they fail to institutionalize the change, leading to that quick regression after some initial success?
It often comes down to what's called the quick fix mentality. Management sees those massive low-hanging fruit gains early on.
Yeah, the easy wins.
Exactly. Simple things, maybe cleaning up workstations with 5S, maybe some minor SMAD improvements. They get excited by the initial jump in metrics.
Right.
But then they fail to institutionalize the deeper, harder cultural changes. They stop doing the really difficult work, the system thinking, the daily Kaizen. And that leads, predictably, backsliding, regression.
It takes time.
It takes years. Ono himself spent over 30 years honing the TPS culture at Toyota. So expecting a complete sustainable transformation in, say, 18 months, it's just not reasonable. It takes sustained effort and leadership commitment.
So what are the key non-technical shifts, the cultural changes needed to fight that regression and make lean actually stick?
Well, the most fundamental one, I think, goes right back to Jidoka. It's creating a no-blame environment.
No blame. Explain that.
Think about it. If you ask an operator on the line to pull that octo-N cord, to stop production because they see a defect,
Yeah.
and they know that stopping the line is going to result in them getting yelled at, maybe disciplined, punished for disrupting the flow.
Yeah.
What are they going to do?
Hide the defect. Pass it on.
Exactly. They'll hide it. So the entire engineering goal of Jidoka, instant fault detection and correction, becomes completely impossible without that cultural foundation of no blame.
So the focus has to shift.
Entirely. From fault-finding pointing fingers at people to fact-finding pointing fingers only at the processes. Mistakes aren't reasons for punishment. They're seen as golden opportunities to learn and make the process itself more robust.
That's a huge shift for many traditional management styles.
Huge. Another hurdle is fighting simplistic thinking, especially at the executive level.
What do you mean by simplistic thinking?
Well, executive teams, they often get energized by those simplified success stories they read about. Case studies that conveniently ignore all the bumps and bruises, the political fights, the setbacks involved in real cultural change. They want to believe transformation is just a simple, linear project plan. But any profound change journey involves complications. It involves confronting entrenched thinking, maybe taking a few wrong turns.
That's messy.
Cultural development is messy. It requires acknowledging that, embracing the learning that comes from the mess, and having the patience to work through it.
Okay, let's touch on standard work. To an operator, standard work can often feel like just more management paperwork, something that restricts their autonomy. How does it fit into this positive cultural shift?
Yeah, standard work is probably one of the most misunderstood lean tools, especially in Western implementations. Yes, okay, it is a tool for management and auditors to ensure consistency. But that's not its primary purpose in a true lean culture. Its primary purpose is actually to enable Kaizen, continuous improvement.
How so?
Standard work is simply the documentation of the current best-known way to do the job safely, efficiently, and with high quality right now. It establishes the necessary baseline.
So instead of being restrictive, it's actually the starting point for challenging the process.
Precisely. You cannot systematically improve a process if you don't have a clear, agreed-upon understanding of the current state. Standard work provides that baseline. It ensures we consistently do what's been shown to be effective. And by having it documented visually, right at the workstation, you give the team a concrete structure they can measure against, analyze, and then challenge to find an even better way.
And transparency is key there.
Absolutely. Using visual controls like those Jidoka boards for leveling production or the and-on lights allows managers, team leaders, everyone to audit the work quickly, to see if the process is running as designed in just a minute or two. That enables immediate feedback, and those rapid response PDCA cycles plan, do, check, act.
It really is abundantly clear then. Lean engineering isn't just about the tools and techniques. It's a deep systems thinking challenge. It involves psychology, sociology, just as much as it involves hydraulics or mechanics.
That's a great way to put it.
The technical applications, tack time, SMD, OEE, they're profound. But it's the behavioral changes required, that no-blame culture, the discipline to actually stop the line when needed. That's what really separates the truly successful lean operations from the imitators.
Indeed. And maybe a final thought to leave people with. Remember the biggest waste of all. The one that often hides or enables all the other inefficiencies. It's inventory.
Right, inventory covers up problems.
It does. But here's the twist. While inventory is definitely a waste, it's often also a necessary response to system variation, just so you can maintain the required production rate. Therefore, if you really want to reduce inventory, and you can't just cut stock levels, you have to first eliminate the underlying variation that makes the inventory necessary.
So attack the root cause, not the symptom.
Exactly. You can't solve an inventory problem by just cutting stock. You have to attack the real enemy, system variation, whether that's machine downtime, quality defects, supplier issues, whatever it is causing the instability.
A powerful final point. Attack variation first. Until the next Equation Design Junkies, we are mechanical engineering made simple.
Stay balanced, stay precise, and never stop building.